Let us understand how do we prove an inequality using the method of induction. Master Skills with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken up a very interesting question where we are going to prove using the method of induction. The question here is: prove by method of induction that log to the base 2 of x is less than x, where x belongs to natural numbers. You can always pause the video, answer the question, and then look into my suggestions. Well, those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. As you know, our students are right there on top. We can be part of your success. Great. So now let's try to understand what is the method of induction? How do we use it to prove, in this case, inequality, right? So we need to prove that log to the base 2 of x should be less than x when x belongs to set of natural numbers. So in the method of induction, we should first check, is it true for x equals to 1, right? So if I substitute x equals to 1, I get log to the base 2 of 1. Is it less than 1? Let's just check it, right? So log to the base 2 of 1 is 0, and that is true, correct? So that means we could apply this method. Now the second step is we'll assume, right? So what are we going to assume? That for x equals to k, it is true, right? That is what we'll assume. And so we have log to the base 2 of k is less than k, right? So that is our assumption, is less than k, right? So, okay, great. So that is our assumption. Now, let's move forward. And what we need to prove is, let's write down here. Now we need to prove that log to the base 2 of k plus 1, so 1 more than k, right? K plus 1 should be less than k plus 1. This is what we need to prove. Is that clear to you? If we prove that, that means this particular inequality is true for all the values of x where x belongs to natural numbers. So what we are going to do is begin with what we have assumed, and that is log to the base 2 of k is less than k. So our strategy is to add 1 on both the sides. So if I add 1, I get 1 plus log 2 of k is less than k plus 1, correct? We added 1 on both the sides. Great. 1 is basically log to the base 2 of 2, right? That is 1. And we'll add this to log to the base 2. And we know that is less than k plus 1. Great. Now, applying the properties of logarithms, when you add, that means we have log to the base 2 of 2k, right, is less than k plus 1. Perfect. So that's what we have. As you know, k is actually greater than 1 because we checked natural numbers starting with 1. For 1, it is true. K is any number greater than 1. Correct. So that also means something more than that, right? So what does it mean? It really means that log to the base 2 of this is 2k. 2k means k plus k, right? Is less than k plus 1, right? So since k plus k is less than 1, and we know that log to the base 2 of k plus 1 will be actually less than log to the base 2 of k plus k, right? And therefore, from statement 1 and 2, we can say that log to the base 2 of k plus 1 is actually less than k plus 1. Is that clear to you? Right. So we infer from these statements when log to the base k of k is less than k plus 1, then k plus 1 is also less than k plus 1, right? Because log to the base k of k is greater than k plus 1. Is that clear to you? That is how we can actually use the method of induction and show that log to the base 2 of x is less than x. And therefore, we can say that log to the base 2 of x is less than x, where x belongs to the set of natural numbers. Make sense? So these are the steps to be followed. I hope they are absolutely clear. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. A request from Anil Kumar. Feel free to support our channel whenever possible. Thank you and all the best.